Thank you for joining me for today's video. Mr. Ish here. It makes sense that as we're coming near the end of the topic on vectors, I present a quick video regarding review, just covering all the basics that we have discussed in the previous two videos. Remember again the difference between a scalar quantity and a vector quantity. Both of these are quantities. A scalar is a quantity which has only a single dimension to it, and that is represented by means of some term. It could be like a magnitude, but a single dimension exists with regards to scalars. Example of scalars can be like mass, temperature, length, because when you measure or calculate these items, when you're calculating mass, you're only getting a single quantity, that is a measure of a matter. When you're measuring temperature, you're only getting a single item out of it, the measure of thermal energy. With regards to length, again, a single item, a single dimension is being studied, how long something is. But when we're talking about vectors, we're talking about magnitude also, and in addition to that, we're talking about direction. So keep that difference in mind. Here you can have something called force. A force is made of mass and acceleration. You see, you got two dimensions in here. Another example alone can be just acceleration. Acceleration is a multi-dimensional quantity. It depends on the change in speed over time. Not like a steady velocity, but a change in that velocity over a period of time. So you have multi-dimensional effects going on. So keep that in mind as we go through this review. If supposedly P represents some vector, you can represent it as some start point going up towards some end point. You see here you have a starting point and you have an ending point. You could have some coordinate over here, x1, y1, and here you can have some ending coordinate here, x2, y2. These are different ways of representing a single vector, but the most easy way would be just a letter with this symbol on it. That represents a vector. Remember, with regards to vectors, the magnitude and the direction, you want to be focusing on how long. With the magnitude, you can show like how long the arrow is. That can give an indication of a magnitude. With regards to the direction, we want to focus on the angle with respect to some sort of reference point. All right, reference point here, our reference point can be either the horizontal, it can either be the horizontal axis. A horizontal axis would be y equals 0, which is 0 degrees. It can be 360 degrees, it can be 180 degrees. These are all good reference points with regards to the direction of a vector. You can also use north, south, east and west as reference points for a direction, with the north and the south being the primary means of representing direction. Something with regards to its easterly or westerly direction with the north, or easterly or westerly direction towards the south. Next, we should quickly revise some of the formulas we have learned in vectors in the first two videos, and then we will end with a quick example. If U represents a vector, it has origination here at the origin 0, 0, but it ends over here, let's say at 5, 5, right? You know, with regards to this vector U, you can determine its magnitude. You can determine the magnitude by doing the square root of the sum of the individual components. Here's my U1, here's my U2. So you can determine the magnitude using this. And remember, magnitude is one of the components of vectors. You take 5 square, you add it to 5 square, you take the square root, and that'll give you the magnitude. What about the direction of a single vector? You can determine the direction using this. The theta, you can use the tangent formula. Remember, tan theta is always equal to the y or the x, the vertical or the horizontal or the sine component over the cosine component. If you take this point over here, 5, 5, imagine this point 5, 5 is right over here. You know 5 represents your x value coordinates, and the 5 also represents the y, the vertical distance over here. So these are already giving you your dimensions you need for this formula right here to determine the angle or the direction of this vector with respect to the horizontal. So just by having a point with reference to the origin and a point on this vector, the endpoint on that vector, you can easily determine the direction, and from that same point you can also determine the magnitude. So these are two very relevant formulas. In the case where you have two vectors, and you're trying to determine the angle between these two vectors. If this is vector u and this right here is vector v, you got to use a different formula. The angle over here, if you remember, is cosine theta is equal to the dot product of these two vectors, the dot product, divided by the magnitude of the individual vectors. But what exactly is a dot product? If you know, thinking back to the first video, I showed you the dot product would be u1 times v1 plus u2 times v2. And u1, v1, u2, v2 represent the components of these vectors. This u would be represented as this, u1 and u2, your x value and your y value, right? And the v would be v1 and v2, your x value and the y value. So here's your u1, here's your v1, here's your u2, here's your v2. Plug them in to determine your dot product. Once you have determined the magnitudes of these individual vectors using the formula such as this, you can actually calculate the theta. Remember, the theta will involve the arc cosine of this part over here, the calculation. Easy formulas. But how does all of this play out in an example? I will show you that. Take a look over here at this board. This is how our video is going to end today. It's going to end with a comprehensive example. We have given only two items. The two items are given are the endpoints of these vectors u and v. Imagine this point over here, the endpoint of this vector is, let's come up with the number 10, 3. Let's use this brackets. So this right here is 10, 3. What about the endpoint of vector v? The v vector, both of these starting from the origin, ends at, let's say, -4, 5. You know these are vectors and they must have a magnitude and they must have a direction. We have to determine the magnitude and the direction given only this. Their origin represents the starts of both of these vectors, and these points represent the end of both of these vectors. And given only that information, we have to determine the magnitude, the direction of each of these vectors. I want to determine the angle between these, and I want to determine that if these two vectors were added to give a resulting vector or a resultant, I want to determine the magnitude and the direction of that resultant. Very quickly, if you look at the parallelogram method and assuming all of this is drawn to scale, of course this is 10 and this right here is -4. Let's make it a little bit more plausible. If this is 10, -4 would be something of this length. If you draw a quick parallelogram, you know your resulting vector should come out somewhere over here at this angle. And remember, we're going to be using our horizontal axis y = 0 as our reference angle, or reference to which we will determine our angles. The first thing we want to do is determine the magnitude of u and v. And the procedure for that is actually, as you know, easy. You're going to take the square sums of both of these numbers, 10 square plus 3 square. We'll calculate that. For v, let's determine the magnitude, again using the same formula, -4 square plus 5 square. We'll calculate all of this. And let's do that. 10 square plus 3 square is a square root of 109. So the magnitudes have been determined for u. For v, it will be 16 plus 25. 16 plus 25 is the square root of 41. Good. Square root of 41. Next, what we want to do is determine the directions of these. Remember, I haven't even given you the directions, but how will we go about doing it? This is where simple trigonometry will come into play. If I know this endpoint for this vector is 10, 3, if I just draw a line down here and make a right triangle, I know this length over here is 10, and then this right here is 3, and this right here is my angle. All I have to do, as I said in the previous image, is use the tangent formula. Tan theta is equal to opposite over adjacent. And then when you solve for tan, or for this theta using the arc tangent formula, which is inverse tan 3 over tan, you get 0.3 inverse tan. 0.3 inverse tan, you get 16.69. But in the interest of convenience, let's get rid of the decimal. 16.69 and make it 17 degrees. So now I know u has a direction of 17 degrees with respect to the horizontal. I want to determine the direction with respect to horizontal for vector v. The only way I can do that now is to calculate this, the angle between the two vectors using that cosine formula. And I'll show you why I have to do that first, then determine the direction of v. Look, cosine theta is equal to, for these two vectors, their dot product divided by the magnitudes of each. What's the dot product over here? The dot product will be u1 v1 plus u2 v2. So u1 times v1 plus u2 times v2. All you have to do is plug in the numbers. Bad 2 over here. Plug in those numbers. What's u1 times v1? 10 times minus 4 is a minus 40. And then I have 3 times 5 is a 15 plus 15. Minus 40 plus 15 gives me a minus 25. My dot product is a minus 25. Now I have everything I need to calculate this angle over here. This theta angle right over here between the two vectors. I have a minus 25 divided by square root of 41 multiplied by square root of 119. This is magnitude of u, this is magnitude of v. Let's calculate for this theta and get that angle. 25 minus divided by 41 square root divided by 109 square root inverse cosine. I get 111.9. I'll round that up to 112 degrees. 112 degrees. Now look over, this right here represents 112 degrees. Right here. So what's the direction of v? If I know this right here is 17, and from here to here it's 112, then from horizontal all the way to v must be the sum of those two. 17 plus 112. 17 plus 112 gives me 129 degrees. Now I know it's 129 degrees. See, if this right here is 17, then from here 0 all the way up to the v must be the sum of these two, which is 129. All we gotta do now is talk about the resultant. Alright, this resultant, which is obtained right here from the addition of these two vectors. And you know the procedure for that. You needed to have the magnitudes and you needed to have the directions, and we have that. Let's look at u. For u, the magnitude is root of 109, and then you gotta multiply it by in the directional components. Cosine 17 and sine 17. See, cosine 17 and sine 17, the directional components of this vector. Let's look at v. V is magnitude root 41, and you multiply it by its directional components, cosine 129 and sine 129. All you gotta do is add these to get your resultant components. You're gonna multiply root 109 with this and root 109 with that, likewise over here. I'm going to do this all in a single step. I'm going to multiply these over here and add them up. Then I'm going to multiply these over here and add them up. I'm going to do cosine of 17, multiply that by square root of 119. I'm going to add that to the product of these two numbers. 129 cosine multiplied by 41 square root. I get a 5.95. 5.95. When I'm done, I'm going to recheck to see I've not made a mistake. Now I'm going to do the sine components. 17 sine multiplied by the magnitude 119 square root plus 129 sine multiplied by the v magnitude 41 square root, and I get a 8.03. Before we actually take this as our acceptable answer, we should recheck our work. 17 cosine times 109 square root plus 129 cosine times 41 square root. This looks good. Let's do the sine version. 17 sine multiplied by 109 square root plus 129 sine times 41 square root. Looks good. 8.03. Now to actually find the resultant magnitude, you know the formula for that. Create these two lines and do the square of the sums of these and their square root. 5.95 square plus 8.03 square, and square root it, I get 9.99. I'm going to round that up to 10. To find the actual angle of this resultant with respect to the horizontal, use the tan formula. Inverse tan, because tan theta is equal to y over x, inverse tan of the theta will equal, see, the theta will equal inverse tan of 8.03 over 5.95. The y over x, or the sine or cosine, divide these numbers and take the inverse tan. 8.03 divided by 5.95 inverse tan, and I get 53.5 degrees. 53.5 degrees. So my resultant right over here has a magnitude of 10, and it has a direction of 53.5 degrees with respect to the horizontal 0 degrees, alright, with respect to 0 degrees. It makes sense. You have a very large vector closer to 0 axis being affected on the other side by a smaller vector but at 112 degrees. Of course, your resultant will be somewhere in between, but this somewhere in between will be closer to this u vector than it is to the v vector. So it's all laid out over here. All the various formulas we've looked at in the previous two videos are shown right here. In this example, you have the benefit now of looking at this in a paused mode, and you can just look at this screen and rework this out on your own. I hope you enjoyed this quick review. Please like, subscribe, and share. Thank you for watching. Have a nice day.